Okay, like I said, today's webinar is going to focus on the Fledermaus-ArcGIS integration. This whole month has been focused on Esri, so if you've been on any of our other webinars this month, you've probably heard a bit of this before. So we're going to be repeating. We really want to make sure you understand how this integration works and how you can benefit from it. Andy and I are going to be going through a sample workflow, kind of focused on a hydro organization, but basically I'm going to be showing you what's done in Fledermaus and then how it moves to Arc, and then Andy will show you how you can do some things in Esri. It's going to be quick, it has to be, to try and keep it under an hour, and it's not going to be super detailed. I am going to blow through a lot of stuff, so if you have additional questions, please feel free to email me and I'll try to help you out. And a lot of the stuff I fly through, for example, when I talk about Bathy processing, we have full webinars that we've already recorded about that, so there's additional resources available. Just an overview of our presentation today. I'm going to start with just a slide or two reviewing the FM ArcGIS integration. Then we're going to talk about Fledermaus. So I'm going to just give you a summary of the workflow that I'm going to go through in Fledermaus. Then we're going to stop the PowerPoint, I'll go into demo, and I'll show you using DMagic and Fledermaus how you would progress through the basic bathymetric processing workflow. I'm going to end by transferring things to an ArcGIS geodatabase. Andy's going to pick up from there. He's going to take objects from the geodatabase and move them through Esri and do some different operations to show you what a person might do there with this data. He'll start with a little PowerPoint slide and then he's going to go on to demo as well. Alright, so just reviewing our integration. Again, if you've been on any other webinars this month, we've been over and over this. But why did IVS, now QPS, decide to work with Esri? Why did Esri decide to work with us? We just, by working together, we can improve and extend the client workflow for our mutual clients and eventually not mutual clients. So right now we're focusing on the clients we have in common, hydrographic offices, survey companies, and making their workflow easier, in the hopes that after we really perfect this, that it will bring in people who are maybe not Fledermaus customers or Fledermaus bathymetric type folks who aren't really in the Esri world yet. So we just want to make your workflow easier and better and go from there. How the integration works, we support certain objects. And so this is an integration where you can take data in Fledermaus and directly transfer it to ArcGIS. The supported objects include Bathy features, so depths, sounding depths, special soundings, contours, ancillary data like coastlines, profiles, and interpretations, and then raster data, bathymetry, backscatter scalars, hill shades, so sun-illuminated images, the bag, which I'm going to talk about on the next slide, and imagery, things like side scan sonar or backscatter imagery as well. If you're unfamiliar with the bag, as we've been doing these presentations this month, I've noticed a lot of questions about what is a bag, and not everyone knows what a bag is. A bag is a bathymetric attributed grid. I just copied this description here from the NOAA NOS site, and that's the location where I took it from. Basically, it is a gridded surface where you have XYZ grid and you have an additional attribute, and that attribute in the grid is the uncertainty associated with the depth. So you have a nice description here. The bag came out of the Open Navigation Surface Working Group. They also have a website which you can access here. The bag is the format that NOAA and NOS use to publicly post their data. So it's an accepted hydrographic product here in the US, maybe not so much in Europe and in other parts of the world, but it is used by NOAA here. We have, when I get into how the bag works, right now when we transfer a bag, I'm going to do two different one bag transfer from Fledermaus and one bag export. A bag transfer, how that will work when I do it, when we transfer a bag to the geodatabase, GDB stands for geodatabase, what you get is a point file. It's a gridded point file that has XYZ information and the attribute information, and that attribute is the uncertainty. So when you open that file in Esri, this is what it looks like. It's a gridded point file. So see that you have the points in a row. And if you were to look at the table that's associated with it, you have the XYZ, the depth attribute, and then you have the uncertainty for each of those Z's. All right, so that's how the transfer works now. That's not an absolute true bag, as a true bag is a raster or grid type product. This was the first transfer we did. It was before Esri natively supported the bag, but now they natively support the bag. So the other option is you can do a bag export from FlaterMouse. I'm going to show you how to do that. And when you do a bag export from FlaterMouse, it's a true raster grid with uncertainty. This is what it looks like in FlaterMouse. I don't have it up in ArcGIS, but if you were to open a bag in FlaterMouse, you get two objects, and hopefully you can see my data object list here. I have an SD file and its uncertainty, and both of those files come in as part of a bag. So you get the gridded bathymetric surface, the XYZ, and then you also get a scalar of uncertainty, so the XY scalar. All right, so that is the two different types of bag that you can get, but this is the true bag as described by the on NOS and other locations. All right, so just basically this is what the integration, how it works, a little schematic. You have data coming into FlaterMouse, raw soundings, ungridded data, dense multi-beam bathymetry. It comes into FlaterMouse where we can do our bathymetric processing and we can create products. This products can then go into the geodatabase, and from the geodatabase can go into ArcGIS desktop or the Esri web applications. We also can have raw data now coming into FM GeoCoder Toolbox, or FMGT, which is our backscatter processing module. There we can create backscatter mosaics, transfer the mosaics and information into the geodatabase, and again move to ArcGIS or web applications. You can also have extra data coming in from other sources, grids, polygons, contours, etc. They can be coming into FlaterMouse or the geodatabase for use in either. And this interaction between FlaterMouse and the geodatabase is two-way. So you can load data into the geodatabase. You can also transfer data from the geodatabase to FlaterMouse directly. So two-way interaction. With FMGT, it's one-way. You can only transfer to the geodatabase. This is what this integration looks like on your computer. So here you have FlaterMouse. You will link to an Arc workspace that will set you up a connection to a GDB or geodatabase. And then if you open Arc Catalog or Arc Map and make a link to that geodatabase, you also have the data available there and can easily be dragged into your ArcGIS project. Again, two-way transfer. So if you do something over here, save it into your geodatabase, it'll be available in FlaterMouse. All right, so I'm going to go into my workflow. The first part is going to be what you do with FlaterMouse if you were to be getting some hydrographic data. So we're going to be using some .all data that came from a Kongsberg sonar. I'm sorry, we're not. We're going to be using some GSF data that came from a Horizon sonar in the Portsmouth area, Portsmouth, New Hampshire. I'm going to show you how you take that data from the soundings. You're going to create a project in DMagic. We're going to load source data. This is ungridded GSF or generic sensor file data. That could be any ungridded data. So don't focus on the format, focus on the fact that it's ungridded bathymetric data. We're going to build a PFM from the ungridded data. I'm going to show you how you can edit QA and QC that data in FlaterMouse using this PFM object. From FlaterMouse, we're going to create additional projects like contours and selected soundings. Then I'm going to take all the information and I'm going to transfer it into an ArcGIS database. Once from there, after I do the transfer, we're going to turn it over to Andy and he's going to show you the next step. All right, so move on to the demo. I'm going to minimize my PowerPoint. I'm going to start, I'm going to be bouncing back and forth with DMagic and FlaterMouse. I'm going to demo how to do certain things, but then I'm going to be opening existing projects just to make this go a little bit faster. So the first step, if you just got your ungridded data, you would open DMagic. This is ungridded data, it's not been cleaned, you're starting from scratch. The first thing you would do is create a project. So to create a project in DMagic, you just go to File, Create Project, you pick your location. I'm going to call this webinar Portsmouth Survey and UTM 19. You make sure the location is correct, so I'm saving this project in my Portsmouth projects folder. If you don't set a location, it sets to default. You set the coordinate system for the project. This area is in UTM 19 North, So I select that. Vertical datums, right now this is a placeholder. Unless you need to set your vertical datum, I tell people to leave it undefined. You can only set it very generally to unspecified meters, feet, or survey feet. I tend to leave it undefined as it's here for when we start supporting vertical datum transformations, but we don't do that yet. So I just leave it as is. You say OK. And that's going to build your project. A project is a set of folders that are put on your hard disk that allow you to organize your data. The next step you're going to do is add your source data. So you right-click and say Add Ungridded Data. That will add any type of ungridded multibeam data. You select your files that you want to add. So I'm going to step through this wizard, but I'm not actually going to physically add them. You would either say Add File or Add Directory. If I was adding a bunch of GSF files, I can say I want all the GSFs. So I'm filtering. I can say Add Directory, and I can go get my GSF files. That will go through my folder and all of my subdirectories, and it will pull out all the GSF files. You click Next. You set your coordinate system for the import data. You could preview the source file here to see what the coordinate system is. This GSF file, as I think all GSF files, is in latitude and longitude coordinates. So it's unprojected geographic. So my input coordinate system is WGS84. The input configuration is read from the source file. You only really have to worry about that if you have XYZ type data. And if you have to change which columns are which, you can do that in the Configure button. At this point, you would click Finish, and it would start loading your data into the project. And that's where I'm going to skip that because it takes a little bit too long. And I'm going to bring an already created project over for us to look at. Alright, so this is DMagic. This is a project I created earlier. And you can see in my ungridded, I have the GSF files loaded here. So when I click on GSF, it selects all of my GSF files. I also have some .all files loaded down here. But we're going to be focusing on this GSF. If I zoom in, you'll see that these are individual yellow lines for the navigation track. Alright, so that's your source data and how it displays in DMagic. The next step in the hydrographic workflow is to create what's called a PFM object. Our PFM object is what we use for editing multibeam data. So it creates a series of surfaces that you can, from the surface, access the soundings, clean out rogue soundings. You can also create a cube surface, and you can validate the cube surface, and from that you can generate clean soundings, a bag product, selected soundings, etc. If you're unfamiliar with the PFM object and bathymetric processing, we do have some old recorded webinars about that I can provide if anyone's interested. Alright, so from the ungridded data, we're going to create a PFM of this whole survey area. The way that you create a PFM is you click on your ungridded data. So I want to do this whole area. So the easiest thing for me to do is click on GSF, which selects all of the lines that are under the GSF folder. I have many, many GSF files here. It selects them all, and from there I can choose to build a PFM of all of them. Now if you only wanted a certain area, I can instead select a portion of the survey and build a PFM from there. There are different options, but in this exercise we're going to be doing a PFM of the whole area. So I select Ungridded, click on the GSF folder. The GSF folder will select every file that is within that directory. Then I right-click and say Build PFM. It's going to load all the GSF files that are in my project. So you see there's quite a lot there. If you want to generate a bag, you have to use Cube. If you're unfamiliar with Cube, you have to watch the Bathy processing webinar. Cube is an algorithm for bathymetric data. It's combined uncertainty bathymetric estimator, and the product from Cube is the bag surface. So if a bag is a product you need to use Cube. So I would check that on there. I'm going to step through this very quickly, but not actually build the PFM. I have one built already. So you click Next. Your input coordinate system is already set. That was set when you added the data. Your output coordinate system is based on your project, so you can just leave that be. Click Next. These are the bounds of my survey area. You can set these to be the bounds of your entire survey if you're planning to append later. Because I'm building a PFM from an existing project, I can just go with what's here. Click Next. Alright, at this point you set your Z range. I'm going to go with what's scanned in. You set your bin size for your data. My data is 1 meter data, so I'm going to set my bin size to 1 meter. Vertical resolution has to do with how big the PFM is, the space that's allocated for the PFM. Unless you're in really deep data, leave it to the default, a centimeter. For the cube capture distance, the next few slides in this bit has to do with cube, and I can't go into the details because it's not the focus of our webinar today, but the cube capture distance has to do with what soundings are propagated back to the cube node. I'm just going to set a fixed distance of 1. There's different recommendations for that. I'm just picking that because it's easy. You do the cube resolution algorithm. That's how cube decides which hypothesis is correct. I'm going to go number of samples, and then you set estimate, offset, and horizontal error. I have shallow data, so the recommended values for shallow data are 2 for an estimate offset and 0.5 for horizontal error scale. If you don't know anything about cube and you're not planning to use cube, you never have to fill this in, so don't worry about it. Click Next. You have to assign the error to build a cube surface. You can have error that comes from your file directly. So if you have vertical error and horizontal error fields, you can do that. You can assign error based on IHO uncertainty. You can assign a specified constant error, or you can use an error model and vessel configuration file to assign your error to your data. I don't have any error, so I might use just the standard deviation option. Click Next. You can have custom filters on your data. This will let you cut out things like outer beams. I'm not going to do that, but if you want it to, you can enable custom filters and say something like if beam angle is greater than whatever, mark it as suspect. That's an option. I'm not going to do it. Finally, you give it a name and you click Finish, and it's going to start building your PFM. A PFM building is quite, it takes a while, so obviously we're not going to do it live. So I'm just going to cancel out of here. I've already built a PFM. When you have a PFM built, it'd be loaded down here in DMagic, and here it is. When you look at it in DMagic, you have a pink pink surface, I should say, and that's showing the area of your grid. From there, that's all you do in DMagic. You build project, you add source data, you build PFM, and from there we go into FlaterMouse. So I'm going to open up FlaterMouse. I can just minimize DMagic. And in FlaterMouse, to open your PFM, I already have mine open, but to show you how to do it, you would go to File, Open Data Object, and if you navigate to your project, this is my project file here. Sorry, this is the one I'm going to be using. In your output, in your PFM folder, once you create the PFM, you'll have a PFM SD file, which is a special kind of SD file for FlaterMouse that is tied to the PFM, and you have all of your PFM data. All right, so that's how you load it. Mine's already loaded, so I'm just going to turn it on. All right, so let me clear my extraction. This is what it looks like when you first open it, and this is your survey area. You could, for a small survey like I have, extract the entire area. If it's a large area, you would use the selection tool and just extract the selected region, which will bring up the surface. I'm going to bring up the whole thing. All right, so this is our PFM. You're going to use the PFM to go through and look for areas that need your attention. You might, if you were going to do area-based editing, I might focus on the shallow edited surface, and I would look for spikes in my data. If I found an area that looked like it might have errors in it, I would use the selection tool. I would launch the 3D editor, and that will give me access to my soundings. From the 3D editor, you can do things like color by line, and what you're looking for is if there's any erroneous soundings in the data. I have 2 lines here, so this feature looks correct. Now, if you found data that you thought was bad, you can use the selection tool, select it, and click Reject, which will mark those soundings as rejected. I'm not going to do that because this data is actually already pretty clean. but that's how you do area-based editing. When you do the rejection, it will automatically update the PFM and update the surface. The other tool that you have with the PFM is the cube surface. So because I chose to build with cube, I can turn on my cube edited surface, which will give me the surface that the cube algorithm came up with as the correct option. Just give that a couple seconds to load. All right, so we're looking at the cube edited surface, and this data is pretty similar because this data is actually pretty clean already. With the cube edited surface, you might color by something like the number of hypotheses. If you're unfamiliar with cube, what cube does is it goes through your bathymetric data and it generates hypotheses of where it thinks the seafloor is. So now I've colored by number of hypotheses, and I'm just going to tweak my color map. For this data, I have between 0 and 23 hypotheses. Probably in most of my areas, I have 1 hypothesis. So I'm going to narrow down this user range to show me between 0 and 4. And then that focuses your eye on areas that have more than 1. You can see here that 1 hypothesis is a bluish color. If I get to green and yellow, I'm looking at 2 or 3 hypotheses. So there's multiple options for where the seafloor is. I can pick on a location with multiple hypotheses. Select my area, again bring up my 3D editor, and instead of looking at the soundings only this time, I can also look at the hypotheses, and I can look and see if cube has chose the right option, and if there's an alternative, why was that alternative there, and are those soundings actually the seafloor. So that's what cube looks like. Again, can't go through it in detail, but basically when you're using cube, you're validating the cube surface. All right, so I'm going to leave there. You would use a combination of either area-based editing or cube, both, to come up with clean soundings. So this surface has already been cleaned and validated. I'm happy with it. I'm ready to go to my products. So soundings are clean. The next step is we can filter soundings. So I've cleaned out, rejected all the bad soundings. Now I can go through and run filters to select soundings for plotting. To do that, I select on my PFM, I go to my filters, and I want to run the scope on the entire PFM file, and the filter that I want to run is the plotted sounding selection filter. There's only one algorithm we have here. It's the NAVO algorithm, and this chooses soundings for plotting on a chart. So this is what you would pass along to your nautical charting folks. When you click Run, you set the chart scale. That's the only thing you set. Everything else automatically sets itself, and you click Filter. This takes probably about 30 seconds to run. So I already ran it ahead of time, but again, all you have to do is change the chart scale here. I ran my plotted sounding filter on my entire PFM. So if I go back and turn on Show Flags and show me the plotted soundings, these flags are marking where the filter has marked the sounding for plotting on the chart. All right, so these are stored as a flag within the PFM saying, all right, this sounding is ready for charting. So that's one product you can create. Another product that you might want to create before we move into the ArcGIS side is contours. To create contours, you can't do contours on a PFM, so you have to do an intermediate step, which is to click on the PFM object, go to Tools, and create a surface object. If you're familiar with FlaterMouse, what this does is create just a SD file, a normal DTM SD, of whatever surface you had loaded in the PFM. I had my cube edited surface loaded, so this is a DTM SD of the cube surface. Once I do that, I can generate contours using our contouring tool. So I can Tools, Contouring. I'm just going to do bathymetric quick intervals. That's going to generate these intervals. It just runs an algorithm and estimates it, but you can also make up whatever interval step you like or insert particular contours at certain steps. I say OK, and that's going to generate contours for my surface. All right, so now I have a bathymetric raster. I have a bag, which is the cube surface. I have clean soundings. I have plotted soundings for the chart. I have contours. I'm ready to transfer my data to ArcGIS to go through the rest of the workflow. To move into ArcGIS, the first thing you're going to do is create an ArcGIS workspace. This is how FlaterMouse sets up a connection to a geodatabase. So I'm going to go to Create, Add ArcGIS Workspace. Puts a new data object in my list, And from here, all I have to do is connect to a geodatabase. I'm going to connect to one I already created. But as we've been doing these webinars this month, a lot of feedback we've been getting from people is, I don't have a geodatabase. We don't use geodatabases. In FlaterMouse, you can create a geodatabase. You can say, I just want to create a file or folder geodatabase, create one, and store it on your desktop and use it as a working geodatabase so that you can use this integration without having to worry about connecting to your organization's geodatabase. Just think of it as a working folder. If your organization has a geodatabase, great, then you can use the integration to the fullest level. If not, just treat it as a folder. Just create your own by clicking folder or file. Create, give it a name, save it on your desktop. It's fine. I already have one created, so it's a file geodatabase, and I'm just going to connect to it. Okay, so here is my geodatabase that already exists. You can see there's already a file in there that I transferred earlier. Now what I'm going to do is propagate data into that geodatabase from FlaterMouse. So let's start with the soundings. You can click on the cube PFM. When I ran that soundings filter, it marked soundings as plotted that's stored within the PFM. So all I have to do is go to ArcGIS, transfer soundings. I'm going to transfer soundings from the entire PFM, accepted soundings only, and I want the plotted records. I say OK. I want to go to this workspace, and I'm going to call these soundings survey soundings. And I'm going to put the chart scale, click on where I want to go, and say OK.
Erin, can I just, sorry, I just interrupt for a sec. There's a couple of people have said they've lost audio on the telephone. I just wanted to check to see. I don't know what the best solution. Maybe they need to dial in again.
Oh, so it's people who've called into the webinar?
Yeah, they're on telephone and say that they've, two people just came in and said they lost audio over the telephone.
Okay, well, let's see if they can get back on.
Yeah, I think they can. Unfortunately, we don't control that. If you can dial back in again, please, or maybe if you have an alternative of going to the speaker or listening to the speakers on your computer.
Yeah, sorry, I don't.
I think Erin will tell us that we do record the webinar, and you'll be available to download. And I just got another message. Someone, Ulf, said that he dialed back in and that worked fine. So please go ahead, Erin.
Okay, great, thanks. Yep, sorry about that. We don't really have any control over the phone. All right, so I transferred those soundings, and now if you look in my ARC workspace, there's my survey soundings. So product 1, soundings for the chart. We've got those transferred to our geodatabase. Next thing I'm going to transfer is the contours that I generated. So I can click on the contour object, ArcGIS, transfer as contours. I'm going to call these a correct contour name, so depth contours, 20,000 for the scale. And I want to go to ARC Workspace 1 and transfer. And that will send that through to my geodatabase. And again, looking at my ARC Workspace, there are my depth contours. You can also, from the PFM, transfer the survey area. So I'll just call this survey extent. And what this is a polygon showing the extensive surveys. It also tells you where there was holes in the data. So if you just need a coverage polygon, this is how you can get that. Andy's not going to use this in his presentation, but I thought I would just export it. You can also transfer the bathymetric raster. So if you transfer a bathy raster, this is just a normal raster or grid file, an ArcGIS grid. So if you're not a person who uses bags, you just want a bathymetric grid, you can do it this way. So I'll call that Portsmouth raster. Then the last thing that you can, well, you can transfer a few things, but the last thing I'm going to talk about is you can do the ArcGIS transfer to bag. Now again, when I go to the ArcGIS button and choose to transfer bag, it's transferring X, Y, Z points with an uncertainty attribute in the attribute table. This takes quite a while to transfer, so I've actually transferred that one already. I'll show you where it is, but I'm not going to do that transfer. You would select on your PFM, ArcGIS, and transfer bag. You can give it a name. Make sure you always click on where you want it to go and say OK. This F00553 1 meter update is my bag transfer. Again, it takes a long time, so I'm just not going to do that one this time. The other option for the bag is to actually export the .bag file, which is the true bag file, and that's what Esri reads natively now. So I am going to show you how to do that. It's not a direct transfer, it's an export, but then can be read directly into the Esri products. So instead of going to the ArcGIS button for the .bag, you just go to Tools, Cube, Export Bag Surface. So I'm going to save this in my projects. Wrong one. Projects. My output folder. And I'm just trying to give standard names to things. So this is kind of how NOAA names their bags by survey area. And then I'm adding 1 meter for the resolution and update. Oh, sorry, I hit cancel. One more time. When you write a bag, it's going to ask you to generate some metadata. So you fill this in, and it's going to write all of this information into your XML file that goes with the bag. I typed this in earlier. I just made some stuff up. You can put in all the proper information. You have to set the vertical datum yourself. This isn't coming from the data. We don't know what vertical datum was used for the data, so don't think that we are reading this properly. That's something you have to set, and it's written into the metadata. Say OK, and that's going to generate the export. All right, so once that goes through, that's it for FlaterMouse. We've done all of our cleaning, we've produced products, we're ready to move into ArcGIS. I've created an Arc workspace with a connection to a geodatabase, and all of my data has been populated into that geodatabase. The exception is the actual bag export, which I just exported from FlaterMouse and saved in my project. I sent all of this data on to Andy, who's now going to take it and show us what we can do with it in ArcGIS. Before we move on, anything that we should do? Lindsay, any questions that we should address before we move on to the ArcGIS portion?
Yeah, there was most of the questions I was just dealing with. I remember I made an announcement about the audio, but someone pointed out that it's hard to hear an announcement when you're not on it. So I was just trying to get out to people by text and question response that for them to dial in. But we seem okay now. There was one question about whether this was putting into a particular data model, and I answered that and said that this was actually just a simple geodatabase that you created, and we're putting data into. We are working on updating to be able to insert into the various data models like the bathymetric information system that Esri is developing, the BAS, the seabed survey data model that's used in the oil and gas arc marine data model. And that will allow insertion. But again, with rasters, they're not really directly in the data models, and normally you can just write those into an associated folder for the raster catalog. There was a question about if it was possible to show the transfer of lines and polygons like an interpretation object, and I guess I don't know whether you intended to do that, Erin, or that was really a separate. It's really the same as the polygons, I guess, for the contours.
It is very similar to the contours. I don't want to take up any more of Andy's time. I've already kind of cut into his time. I tell whoever it was, I'll get back to you via email because I can demonstrate that on a GoToMeeting or send you some instructions or anything like that. But generally, for anyone else who's interested, if you create any kind of interpretation, we have an interpretation object class, or if you draw, even if I draw a profile, anywhere where you see an ArcGIS button, Lindsay, can you put yourself on mute, please? Anywhere where I see an ArcGIS button, you have the ability to transfer. So here I could transfer as lines. And the same thing applies for points, polygons, interpretations. All of those will have an ArcGIS button with the option to transfer. All right. I'm going to then pass it over to Andy, who's going to take us into ArcGIS for the rest of the workflow. So Andy, I'm changing presenter to you.
Okay.
And you're up.
All right. So just to reintroduce myself, I'm Andy Ommen. I work at Esri specifically for the maritime team, and we develop the nautical solution. And what I'm going to go over here today is we've got the data that Erin transferred from Fledermaus. We've got the bag, the bathymetric attribute grid, and we've got plotted soundings and generated contours. We're going to update the BIS, or the bathymetric information system, with the bag data. And then I'm going to update our ENC geodatabase, which has the ENC data model that the nautical solution created, with the plotted sounding features. And then we're going to export those plotted soundings to an SD7 update file. And I'm going to show you how to generalize and smooth the contours that were created from Fledermaus. And we're all going to do this from an open map document. The bag is going to be brought into the BIS using ArcToolbox, a Python script that we have within ArcToolbox. And I'm going to show you some of the editing features within ArcMap on how to add the soundings and generalize the contours. So I'm going to go ahead and jump right into my demo. So as we see here, this is an ENC cell imported into our ENC data model and symbolized using ST2 IHO standard symbology. If we open Arc Catalog, we can see we have the BIS database here. And this is a mosaic data set that holds additional bag files. And here's the Portsmouth survey data that Erin's created and has sent to me. And our ENC product database is hosted on Microsoft SQL Express database. And here's our ENC product database. And here's our model, like feature classes and support tables that all make up the ENC data model. So first order of business is we're going to update the BIS with the bag data that Erin's created from Fledermaus. I'm going to go ahead and drag the mosaic data set into ArcMap. And we can see its layer order puts it at the bottom. Now it's redrawing, it's drawing the data in. I'm going to drag it up to the top of the polygon feature classes. And here we can see the bag data. Now to update this mosaic data set with additional bag content, we're going to open ArcToolbox. And inside the bathymetry tools that we have, we're going to run this Python script called add bag to BIS. There's just two parameters that we need to input. The input bag, which was the exported bag surface that Erin created and gave to me earlier. We navigate to it. And then the target bathymetric surface is our mosaic data set that we just brought into ArcMap. We call it New Hampshire Survey. We click OK, and it just runs the script. Now, right now, it's copying the bag from my local client machine and putting it into this mosaic data set. And once it's complete, we should see the update. We should see the new bag added to the data set that we see here. It's almost done. Now it's computing. It's building pyramids also behind the scene, and pyramids on a raster help rendering capabilities. When you zoom in, you get the higher resolution. Then when you zoom out, it goes to a lower resolution, so it renders more quickly. Once it's complete, we close. And we'll refresh the screen. And there we can see the new bag data that was input. It's along our survey area here. So that's how we update the BIS with additional bag data that we got from FlaterMouse. I'm going to go ahead and turn that layer off so we can work with our plotted data, plotted soundings, and generated contours. If we go back to our catalog, we're going to first update the soundings, the survey soundings that were captured at the 2000 chart scale, which is what our E&C cell was compiled at. I drag the soundings into ArcMap. And they're symbolized as these green dots. I'm going to change that symbology set. I like to use red X's instead, just to show me where those soundings are. So I bring up my symbol selector by double-clicking on the symbol in the table of contents. I change the color. I get color patterns that I can use. I use red, and I'm going to reduce the size to, let's say, 8. And now we can see the red X's of where my plotted soundings from FlaterMouse exist within my E&C cell. So I need to update soundings that are in my E&C with the new plotted soundings from FlaterMouse. So I'm going to run a spatial query. I'm going to use the select by location tool. Now I want to find the survey points, which are my target layer, that intersect the source layer, which will be my soundings feature class. I want to apply a search distance of 5 meters. I can adjust the search distance if I want, but for this purpose, I'm just going to use 5 meters. I'm going to run, and right there, I see I've got a sounding depth of 1.57, which we can round up to 1.6. Let's go ahead and zoom in to where that sounding is within our chart. Well, the sounding on the chart, or the E&C, says 1.5. So, go ahead and clear my selection. I'm just going to draw a little rectangle over the sounding to select it. Now in my feature manager, which shows me what I have selected, I'm going to expand the soundings PE feature class and click on the feature that I have selected here. And now we can see the attributes, which follow the SD7 attribute format, that I have 1.5. I want to make that change to 1.6 based on our plotted soundings. I apply that, and now my attribute's been changed, and we can see it updates in the cell as well, or in our product database as well. Go ahead and clear my selection, and since I'm using my E&C product database is off of an SDE geodatabase, so I have this. I'm using an edit version. I've called my edit version edits, but I need to post this change to our default version because that's where we export our SD7 cell from. So on the nautical toolbar, I have this reconcile, which I reconcile to my parent default version. And once that's complete, I use this post tool. And once this change is posted to default, I can go back into Arc Catalog. I find my product database. Remember, it's the New Hampshire cell that we've been working on. I right-click on the featured data set. I select Export Geodatabase to S57. So we check the cell that we're going to export, the New Hampshire 01 cell. I define my output location. I want to do an update file. I can select a new edition if I want to, but I just want to update the existing cell that I have. So as we can see, this is SG7 metadata. So our edition number is 16, and we're applying the first update to it. I click OK, and now I'm ready to export. So what this does, it takes the data in default, it compares to the last exported cell, and looks for any changes. And all the changes that are made are put into this update file. In this case, we've only updated one sounding, so that should be displayed, or that should be reflected in our export, or SG7 update file. When it's done here, it's going to give me a log so I can look at everything that came out. So we get our SD7 header information, which is standard, and then it shows us that we've updated one sounding feature, and it gives us the time. That's basically how you would that's how we could update soundings on an ENC product database with the plotted soundings from Fledermaus brought into another ArcGIS geodatabase. So finally, I'm going to go over contours. So we have, in addition to the soundings in we also have these depth contours that were also compiled at or generated for a 20,000 scale chart, or ENC, which is what we have here. I'm going to drag these in to the ArcGIS workspace as well. Now we can see that these contours have a lot of jagged edges and aren't very smooth. What we're going to do is we need to stop. Before I was editing my ENC product database. So I'm going to stop editing that workspace, and I'm going to select my actual depth contours that are in the workspace that Erin created earlier. I'm going to go ahead and select that workspace. Now I'm in an edit session. I'm now editing the contours. I'm now able to edit the contours that are in the ArcGIS geodatabase that Erin brought in that Erin created from Fledermaus. I'm going to select this contour. See, it's got gives us the depth CNT. That's the name of the feature class that was created. I'm going to run this tool from the Production Editing Advanced toolbar. It's called Production Generalize and Smooth. These tools come with the Esri Production Mapping and Nautical Solutions. So this dialog gives us some offsets. So this offset speaks about the vertices, the distance between vertices on the line. And you can use different units of measure. I'm going to pick meters. And then there's different algorithms you can select as well. You can just do a smooth algorithm, which will basically smooth the lines. Generalize is what kind of filters out the vertices. Or you can run different iterations of these two algorithms. I'm going to select the generalize smooth algorithm because that's going to give me the best shape of the line. First I'm going to say 15 meters. Now before we can apply that to the actual feature, we have to do a preview. The preview's in red. We can pan down and see, well, this isn't going to work because this contour is collapsed on itself. So let's bump that up to 30 and preview that. Well, that's a little too wide. So let's try 20. That one fits, that one works. We can use this contour. And we click Apply. Our contour was smooth, and now I can copy this and add this to my my ENC product database. Are there any questions of what I've gone over?
Lindsay, was there any questions for?
Sorry, Andy, no, there was no. Yeah, no, I was just unmuting myself, sorry. No, there was no specific questions on the on any of that, Andy, I don't think. I think that sort of shows the flow through the Esri side.
Okay, great. Thanks, Andy. So that was hopefully a demonstration of how we can go from raw, ungridded, multi-beam, dense data through FlaterMouse to several products, and then move those products through to the ArcGIS, and from the ArcGIS bring them into Esri ArcMap and do further analysis, changes to products, and updates to nautical products from there. Andy, if you could just change back to me for 1 second.
Sure.
All right, so just bringing up the PowerPoint. We're actually done ahead of time. That's a record for me. I'm never done ahead of time. If anyone has any final questions, we have a few minutes left. Otherwise, if you have any webinar questions or requests, you can email them to me. If there was anything that we didn't get to in the presentation or something that was a little too complicated of a question for a webinar, we will get back to you via email, either myself or Andy or both of us. And yeah, if you have any bugs, license issues, etc., please email support, or you can contact support from our webpage. Andy, any final words?
No, everything's good to me.
All right, thank you all for attending. Please join us again for our next webinar, which will be sometime in October, not yet scheduled. Yeah, so thank you.